We have a small problem. Our CoMo170D is broken. Well, not entirely. The D in CoMo170D stands for the fact that an energy compensated Geiger-Müller counter tube is installed at the front, which enables the measurement of a dose rate. That is not the problem, it's the 170. That stands for the detection area of 170 square centimeters that the contamination monitor can cover. And it's a plastic scintillation detector with a zinc sulfide coating. This special design allows the measurement of alpha, beta and, to a certain extent, gamma radiation. A scintillation detector, whether plastic or not, uses a scintillation crystal that converts the radiation energy into light signals that can be further measured. The number of light particles provides information on how much energy the radiation had. Here, the different ionization forces of alpha and beta radiation are used to distinguish between both of them. Only a scintillation counter is sensitive to light. This means that it needs to be covered with a film that is so thin but still intact that light cannot pass through it. And that film is torn, which means that the CoMo malfunctions when exposed to light, and I had the honor of repairing this €8,000 device. Fortunately, NuviaTech sells these films individually for self-installation for around €160. Thank you for making a YouTube tutorial so that I can do it myself. With that hefty price tag of the detector, here's a glimpse into my thoughts while repairing this thing. First, unscrew the screws. Then the second grid has to come off.
Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob!
Patrick, the lid's already off.
Since these parts has been assembled for so long, the detector was attached to it. So you had to unwind the foil from the detector because it must not be removed. Now put the foil on, then the rubber seal. I was sweating while doing
Careful,
this.
SpongeBob! Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob!
Switched it on and the detector shows off limit. Why? Well, I wanted to capture this on video, and at this moment the scintillation crystal was so strongly stimulated by all of the lights that the remaining photoluminescence completely overwhelmed the detector. This has to fade away first, and in my case there was so much light during the installation that the CoMo really had to recover with the cap on for the rest of the day. If you need it at the same day, you should do that installation in the dark. And if I, with my poor motor skills, managed to do this installation, anyone in a nuclear laboratory can do this. Although it is not calibrated now, but that's not a problem in our laboratory. I just wanted to show you what else I do in the laboratory. And if anyone needs to change this foil...
Careful, SpongeBob! Careful, SpongeBob! Careful, SpongeBob!
A special thanks goes to the Working Group of Analytics and Fundamental Nuclear Chemistry from Dr. Eric Strupp and the Division of Nuclear Chemistry at the University of Cologne, and to my Patreons. With that being said, thank you for your attention and goodbye!